I'm going to step through the process that I would go through to produce a principal component analysis, or PCA, decorrelated composite of a Landsat 6-channel composite scene. It's relatively straightforward, and it shouldn't take too long, and I'm going to step in and out as I'm doing it because a couple of the processes take a little while. So you can see I have 6 channels open over here. This is an area in the Pacific Northwest around Mount St. Helens, and I would start by making a 6-channel composite, and I do that with data management tools, raster, and raster processing, and it's in the composite. And so I input the channels that I'm going to use, the raster channels, in order, just to keep them straight. 4, 5, and 7. And the only thing I'm going to do here is change the name of this this composite file to 1, 2, 3, 4, 5, and 7, so that I know what it is in case I ever want to look at it again. And I'll probably step out while this is running. That didn't take too long. There's a nice natural color composite, 3, 2, 1, red, green, blue. Give you some idea of what this looks like in a in a normal color composite. And of course, you could probably substitute channel 4 for 2 in that composite if you wanted to jazz it up a little bit, or do anything you want, I suppose. There, see, much greener, a little more visible here. And so now what I'm going to do is I'm going to perform a principal component analysis on this. So again, I go back to the toolbox, and I go into the Spatial Analyst tool set. So you have to make sure that you have Spatial Analyst checked out and turned on. And in the multivariate tool set inside there, right down at the bottom, is a principal components. And so the principal components file that you're going to use is our composite file, and you can see it's going to produce a multiband raster going into the default geodatabase called Princip2, which is fine. It will make 6 components. So it'll produce 6 components. It can't produce more than the number of channels that are going in, or the number of variables if it was a matrix of non-image variables. And so and I'm going to make an output data file and probably put it out on the desktop and call it just MSH data. Okay, and this will be a little text file that it'll have some data that we're going to use later on. So again, I'm going to start this running, and I'm going to step out because this does take quite a while, and I'm actually going to time it so I can tell you how long it does take on my machine. Okay, the principal component analysis has completed. Here's the composite, the PCA composite, and this is channels 3, 2, and 1, red, green, and blue. So it somewhat looks pretty wild, actually, when you look at the colors there. I'm going to switch this around a little bit. I'm going to make it 3. We'll just show you a little bit of what you can do. So it is a 6-channel composite, 3, 1, 2. And typically you would only use, unless you were doing something really special, the first 3 channels in some combination. So here's channels 3, 1, 2. Very wild, actually, almost psychedelic in a sense. So you also do get a data file with this, and again, this is I would guess that a very high proportion of the variance in all 6 channels is accounted for in these first 3 channels. Let's take a look. If you look in the data file, here's the data file that we made that I put on the desktop, and you can normally open this with something like Notepad. You can open it with Word. It's just a text file, but there's a lot of data here. There is a covariance matrix, correlation matrix, which is quite interesting. And there are eigenvalues and eigenvectors. And then this is probably the most interesting part of this, and that's the percent and accumulative eigenvalues, which in effect is the percentage of the accumulative eigenvalues is the accumulative percentage of variance that each component accounts for. So ultimately, all six sets of eigenvalues account for 100% of the variance, the covariance in this multivariate data set, right? And so here you can see the first component accounts for almost 85%. When we add the second component, we're up to almost 94%. And with the third component, we're accounting for over 99% of the variance in this 6-channel data set. And so you can see very little is added by these last 3 components, 4, 5, and 6. There's some other things that you can do. You can look at the individual components. Fairly simply, let's look at 1 here first as a grayscale, and I would do that by setting all 3 channels to the component that you want to look at. So here's component 1, and you can sort of page through that and do that yourself. So principal component analysis. You're going to do this. This is how you would do it. You're going to do it for an image of your choice, and you want to save this data file here, this text file, because you're going to answer a couple questions using this.